Hello and welcome to this talk on ORAQL, optimistic responses to alias queries in LLVM. My name is Hueckelheim and I'm going to present this joint work with Johannes Dörfert, both of us working as assistant computer scientists at Argonne National Laboratory. I'm going to start by motivating this work. As you probably know, alias analysis is a type of analysis that lives in most compilers and in particular in LLVM. And it tries to determine, given two memory addresses, whether they point to the same memory location or to overlapping memory locations. This is important for a lot of performance optimization that happens after alias analysis in compilers. And performance optimization generally works best if we can establish the absence of aliasing, or no alias, in other words. Like most analysis passes and compilers, alias analysis has to be conservative. We have to ensure correctness, and since we can't always statically ensure that two memory addresses do not point to the same location, we sometimes have to assume the worst, which is may alias, so we do not know whether two addresses are the same or not. Now, with our work on ORAQL, we're trying to determine how often does it happen that we are unnecessarily conservative, and how is performance impacted by being conservative, and also in what kinds of programs is the impact the greatest. Now, to do this, we've developed ORAQL, and it has two components that I'm going to talk about in this slide. The first is the ORAQL plugin that lives inside LLVM and is implemented as an alias analysis pass. Now, when alias queries get generated, sometimes they can't be answered by any of the existing passes. And so those queries that are still may alias after all the other passes have done their job are handed down to the ORAQL alias analysis pass. The ORAQL pass will optimistically say no alias to some of these queries without knowing whether that's actually true. These optimistic decisions will then be handed back up the chain and will influence the compilation. They will result in object files being generated and so on and so forth. Now, this is where the second part of ORAQL comes into play, the driver. The driver will take this executable that is optimistically generated and put it through a user-given test. Depending on the outcome of that test, the test might either fail if we have been too optimistic, or it might succeed. If it fails, we will refine the decision sequence to pull back on some of these decisions and be less optimistic. If it succeeds, we will try to be more optimistic. The end goal is to find the maximum number of queries that we can answer no alias optimistically. And as a result, we will get a final sequence, which will hopefully be the maximum number of optimistic queries that we can give. Now, the probing sequence here is also worth talking about, since for most programs, even for relatively small ones, we are faced with hundreds or even thousands of queries that we have to answer. And we can't afford to answer each of them individually and try each time whether the program breaks, because each time we have a compilation and test cycle, and some of the tests can be quite expensive. For this reason, we have a bisection approach, where at first we are trying to be optimistic everywhere, but in most cases there will be some queries, we don't know which ones, that we cannot afford to be optimistic because we will break tests. So if the test fails, we will instead use a bisection strategy where we'll be optimistic only in a subset of queries. And this allows us to then pinpoint the decisions that are actually important since they affect correctness, and find all the other decisions where we can afford being optimistic without making tests fail. I want to stress here that ORAQL is just a heuristic, so it's not a conservative approach that guarantees correctness. It doesn't even guarantee that we find the best performing variant of the program. It's only meant to compile programs for testing and to guide research in alias analysis, or to help program developers understand how alias analysis affects the performance of their programs. We have more plans for this. Right now it's a work in progress and it's only a prototype. We want to work on more probing strategies and extend our test set and eventually merge this into LLVM. If you found any of this interesting, feel free to shoot us an email or ask at the Q&A if you're seeing this as part of the LLVM workshop. Thank you very much for your attention.